Okay, so optimal choices. Now we have discussed the budget line a little bit before, and now we're going to mathematically derive or actually formally introduce the budget line. Yeah. So in our perfectly competitive market, the consumer is endowed with a certain amount of money to spend on goods one and two, which we will denote I for income. The market price of each unit of good Q1 is P1, and the price of each unit of Q2 is P2. So it's has nothing to do with revenue or something, but it's the exact same concept. If we have a quantity and the price per that quantity, then if you multiply them, that's the amount of money that you're spending or making or something. So it should be very obvious. The consumer's budget constraint is the set of all baskets Q1, Q2 that she's able to afford with her income. That is all baskets such that. So it's like I was saying, if we understand the basic math, it is very, very obvious that our budget line is always that. There's two ways that we present it. It doesn't have to be so formal. If there's a correct way, one correct way to say the budget line, it is correct. This is it. Yeah, and I've always kind of looked ahead, so I tend to do something and then it comes right next to the thing. But this is our budget line. Remember, y equals mx plus b. I'm going to derive it too. This is Q2, this is Q1. So it's Q2 is a function of Q1. But we know that if we have less than or equal to, we shade down here. So if we have an inequality, it's going to be a shading technically as our graph. But when I said if we're not so technical, there's two ways. The other way is equally as common. There's two ways that they present the budget line. So one is that it sounds like I'm talking about a concept when I'm not. The other one is just an equal sign. So sometimes if I talk about something, it sounds like an important concept when it's totally not an important concept. It's just true. If there's one correct way to do it, you have to do it with the inequality. We know instantaneously we have a certain amount of money that we can spend, and we're never obligated to spend all of our money. So less than or equal to this thing plus this thing, the two amounts of money that we spend are less than or equal to our total amount of money is the one and only correct way to say it. But assuming that we do spend all of our money, which a lot of homework problems do, then it just becomes an equal sign anyways. So I'm just talking about silly little things that we don't want to get confused on later. Anyways, I'm sure they'll derive this, but just because I'm thinking about it, we're going to do it. There's really only one concept. What is the concept? The concept is just like the ISO cost in chapter 3, we're going to solve for that Q2. If we graph Q2 as a function of Q1, what do we have to have? We have to have Q2 alone as a function of Q1. It is a y equals mx plus b. It is the simplest of all concepts. I might as well just do it. But so what do we have? We have P2, Q2 less than or equal to I minus P1, Q1. Divide everything by what? P2. It is a price. There's no flipping of the sign. Nothing in this is ever negative. Divide both sides by P2. Okay, so it's always better illustrated this way. Yeah, so let's kind of conserve a little bit of space here. But we have Q2 is less than or equal to, or an equal sign is perfectly okay. They always write it this way. I'm going to write it both. Yeah, I don't mean to be so technical, but they always write it this way. It's just we know that it is Q2 is a function of Q1, so we know in reality that this is our M. Let's just kind of burn that in our retinas in the whole book. We'll write it that way. I'm just going to erase it, not the right way. It's already written the right way. I'm going to write it the other way. Yeah, but I'm just going to flip the things there. So it's a y equals mx plus b. But what do we have there? We have Q2 is less than or equal to negative P1 over P2. That's the slope. Q1 plus I divided by P2. And that is our y-intercept. Y equals mx plus b. Yep. And that right there is every budget line that it's basically done. That's every budget line that we're going to have in chapter 4. Yeah. And usually just the budget line if we do have the less than or equal to, then we have values allowed underneath it, but it's going to be the thing that we always said later, where you have the indifference curve, and all this stuff doesn't matter. The only thing that ever really matters is where they intersect and where their slopes are the same. So we're going to have that. But this is the budget line. There it is. And we want to recognize the slope. Remember, the slope is negative P1. I should have said that. The slope, if there's one important thing from that, it is the slope, which is negative P1 over P2. Okay, so I like to kind of do that, show my own understanding other than read, but they'll give us an example. So we can always kind of, yeah, budget line, there it is. And then they give us an example. And then all of this is literally what I just said, I think. Okay, so there they derive it. I derived it, and so did they. So they got the same thing I did. Yeah. So we don't need that there. That's the slope. They have little understandings. They just don't really come up in the homework. But we have that. So what would it be? It would be if P1 and P2 are positive, then this entire thing is negative and the slope is always negative. So they have things like that that are obvious, that are just meaningless. Okay, so there, I didn't realize they were going to write it. I forgot, but I wrote it and then they wrote it. Yeah. So we don't always graph, yes, but this is from the indifference curve. So the indifference curve, which is going to be u equals a function of q1, q2. Yeah, that's the indifference curve. That's going to come up with the slope mu1. It is the absolute value of the slope, but we prefer to say that it's going to be negative the slope. Yeah, so that's the absolute value of the slope right there, or negative the slope. Where does that come from? That comes from, it does come from that, but I guess we're talking about, it's all just notation, so everybody gets mixed up as far as lecturing, but where does that come from? That comes from the budget line that we just did. And okay, we have to be careful there sometimes. Where do they say it? They have to say it precisely. Okay, yeah, so I just forgot that part in the derivation. So we write it two ways. We write it this way, multiply both sides by -1, and we write it that way as well. Yeah, so also write it that way. But we have this right here. We have to do it right. I'm sure they write it in there somewhere. I just don't see it. But I'm talking about him. Let's erase him because we want to write it correct. We want to say that the mu1 over mu2 is going to equal negative P1 over P2. Yes, that will always be correct. See where they go from there. Okay, so utility maximization is just going to show, condition 1, condition 2 for the 3 cases. I guess we'll do that in the next video, but we're going to fly through all of that really quick.